So the last kind of core piece that you should always have inside your own classes is the toString method. So the job of the toString method is to create a text representation of your object. The toString method has this exact header, so it has to look exactly like this, public string toString, and we'll talk about a little bit more about why that is when we talk about inheritance. But for now, just know that it has to have exactly this header, public string toString, taking in no parameters. Okay. The toString method is automatically called when an object is either concatenated with a string or put inside a printline method. So that's kind of a really great reason why we want to implement this method, because that's something that we do a lot. So you can decide what you want your toString to contain, as long as, again, it has that public string toString header, no parameters. And then we just decide what we want our toString method to return. So maybe I decide that my text representation is just going to be the face value, and I'll convert that to a string using integer.toString. So all it's going to be is the string 4 or the string 3. Or someone else might decide they want their text representation to be a little more descriptive, something like that. No right or wrong here. It just depends on the purpose of your program and what you think a good text representation of your object should be. Oftentimes, toString methods will have more code than this. This is a pretty simple class, so it's a pretty simple toString that I've written. But again, the bottom line is just that it's a text representation of the object. So before we included this method, let's just comment that out for a minute. If we had printed out our die object, what would we have gotten? We would have gotten the value of die 1, which if we look back at my lovely picture, the value of die 1 is what's stored right here. And what that is a memory address. So that's what prints out, okay, because that's the value of die 1. But if we do include our toString method, instead of printing out the memory address, it'll print out whatever we put inside our method. So it'll, behind the scenes, it will call and invoke that method. So now it will print out the face value in this case. Okay. So whenever you're writing your own classes, you should include a toString method. And again, it's up to you to decide how to implement that method. So just a little bit more about some of the details of what we've just talked about using that class as an example. Let's talk for a minute about data scope. So the scope of a variable defines where it can be used or referenced, where it can be seen. And what determines the scope is where that variable is declared. So remember that variable declaration is when you specify the type and the name. It's not where you initialize it or give it a value. It's where it's declared. It's where I say int n or string s or int face value, okay? Wherever that declaration statement is, that determines what the scope is. Okay, so if I put that statement inside the class but outside of any methods, that means my variable is instance data. So because my declaration statement is outside of any methods, face value is instance data. Okay, now instance data can be used anywhere in the class, and it also lives in memory as long as that object lives. So these two instance data variables will stick around as long as die1 sticks around. They live with that object. Okay. That's unlike local data variables. So local data is a variable that's declared inside a method. Local data is used only inside that method, and when the method's over, the variable gets garbage collected. So let's say inside my code here, let's say instead of just returning this, I've created a new string s. S is now a local variable. It's local to the toString method, and that means I can only reference S inside this method. And it also means that when this method is done executing, S will get garbage collected. Okay, so it's where that declaration part happens. That's that first part where I state the type and the name. Where that happens determines whether a variable is instance data or local data. If it happens outside of any method inside a class, it's instance data and can be used anywhere in that class and lives as long as the object lives. If it happens inside a method, the variable can only be used inside that method, and it dies when the method ends. So what kind of variable is die1? It's local data. It's local to the main method, and that means that die1 will be able to be used anytime anywhere in the main method, and when the main method is over, die1 will be garbage collected. That also means that any of die1's instance data variables will live as long as die1 lives. So basically they'll persist throughout this whole method. And when that method is over, die1 gets garbage collected and all of its instance variables get collected with it. Okay, so that's an important distinction in scope and variable type. We've talked a little bit about encapsulation, the idea of objects protecting their own instance data, having control over their instance data, and then just providing public methods so that outside classes can both access and appropriately modify the values of those variables. Visibility modifiers. So there are 4 options for visibility: public, private, protected, and then there's the default visibility. And visibility modifiers can be applied to methods and to variables. Now, a public method or variable can basically be referenced anywhere. It can be referenced inside the class, outside the class, pretty much anywhere. Okay? A private variable or method can only be referenced within the class that it's declared. Okay, so you can only reference it inside that class. Another class cannot see it. Protected is related to inheritance, and we're going to talk about that when we talk about inheritance. So I'm going to put a pause on that one for now. And then there is this 4th option of default visibility, which basically means that a variable or a method can be referenced within a package, but not by a class outside the package. I'm going to recommend in general not to use this. I think it's better to be explicit and either declare your variables and methods as public or private. It's not wrong to use default, but it's better practice to be specific about the visibility, public, private, or protected. Public variables, don't do it. Okay, so don't use public instance data variables. We talked about encapsulation. We saw that example of why we don't want outside classes to be able to directly modify our variables, because that would allow them to give them values that maybe wouldn't make sense. So we want to keep our instance variables private. So we do not want our instance variables to be public. Okay. If we have a constant, so let's say, for example, that we did want to support, we wanted some way to reflect that this die had 6 sides. We might create a constant, say called num sides. This it would be okay to make public because it's constant, meaning I use the keyword final, meaning that as soon as I give it a value, that value can't be changed. So it doesn't violate encapsulation having it be public because no other class can change it anyways. The value of it cannot be changed. Okay, so constants it's okay to make public, but instance variables do not make public. Keep them private. It is very bad practice to make your instance data variables public. Now, when we think about method visibility, a public method is sometimes called a service method, and that's really the methods that you want other classes invoking on your object. So that's kind of why you're writing your class, right? Because you want other classes to be able to use it. So you want to make those methods that it supports public. Private methods are kind of support or helper methods. So let's say you had a public method that was accomplishing a very complex task. You might want to break it up into a couple pieces, and then those smaller methods you'd make private because you're not writing them with the purpose of a client or an outside class using them, but you're writing them to kind of help you do something internally in the method, so you keep those private. Okay, so those are sometimes called support methods or helper methods. And again, those are methods that are not meant to be used by an outside class, but they're part of internally what makes your class run. So public methods and private methods, it depends on what the method is doing. Now, public variables can be accessed, again, anywhere. If we have public variables, that violates encapsulation. So we don't want to do this. That's why that one is red. Okay. Private variables, good practice that enforces encapsulation. Public methods are the methods that provide services to outside classes called clients. And private methods are used to support those public methods. Okay, so this is a nice little chart to help you remember when to keep things public and private. All 3 of these are perfectly fine to use whenever appropriate. This one we're not going to use. Stay away from that one. Okay, so a summary of what our classes should look like. They should contain our private instance variables. They should contain our constructors. They should contain our getters and setters, and they should have a toString method. So those four pieces, the variables, the constructors, the getters and setters, and the toString, are kind of your default core requirements for any class you write. So at the very least, every class you write should have those four pieces: variables, constructors, getters and setters, and a toString. Now, in addition to that, then you want to go ahead and add any public or private methods that you want to add, okay? So, for example, back in our die class, what is one pretty obvious method that we'd want to add to this class? It's probably going to be the roll method, okay? So we want a way to roll our die. We don't want to create a new die object every time we want to get a new value. We just want to have one die object in memory, and we just want to change what that value is. Okay, so we want a roll method. Now, our roll method could be void, meaning it just updates the value but doesn't return anything. Or it could also be int, meaning it updates the value and then returns the new value. I could see an argument for either one of those, so it'd be up to you what you want to have the return type of that value be. I'm going to make it void. Again, I could see the argument for making it int. And do we need to take in any information? Do we need any inputs? I don't think we do, right? We don't need any extra information to roll that die, so there's not going to be any parameters. Now, inside our roll method, we're pretty much just going to do what we did before, right? We're just going to create a new random number. As a general rule of thumb for programming, you want to minimize the time that you're repeating code. So if you have one line of code that you are typing more than once, I would argue, you should probably put it in a method and call that method rather than type it again. Also, copying and pasting counts as typing it again, so we don't want to do that, right? The reason that we don't want to do that is because if there's an error in this line, or if we decide to make a change to this line, I only want to make that change once. I don't want to have to go through and find everywhere I copied and pasted it in my code and change it in every place. It's a really bad practice, okay? So if there is a specific line of code that you're executing more than once, think about how you can do that with methods, all right? Now, in our case, really this method probably belongs in this line statement rather, probably belongs inside the roll method, right? That's where we want to generate the new random number whenever we roll the die. So I'm actually going to take this line of code out of my constructor, and instead of having it there, I'm just going to invoke the roll method. So now when you create a new die object, we initialize that random number generator, and then we call the roll method. And the roll method is what generates the new value. So because it's a public method, we can also call that method directly. Okay. Now I'm going to make one other change to the code here. Because I added this constant, I'm going to use it. Again, it's a good idea to use constants rather than using direct literal values whenever possible. So I'm going to take out that 6, and I'm going to change it to num size. Okay, so now I've got my additional method. I could think about whether there's any other methods I might want to include inside my die class. I can't think of any at the moment, but maybe there'd be some that I might want to add later on. But I have my basic building blocks, right? So I've got my instance data variables, got my constructor, getters and setters, and toString, and then I've added any additional methods that make sense for my particular class. In this case, I added one method called roll. Okay. So now in my die tester, I can go ahead and I can roll the die as much as I want. And if I want to know what number was rolled, I can just print it out. Okay. Now, one other thing I want to just mention about this class is that I did not include a getter and setter for random, for my random object called generator. That's because this isn't really an instance data variable, as I mentioned before, in terms of it doesn't really describe my die. It's kind of there as a helper or a support variable. I don't want an outside class being able to access it. There's no reason that an outside class should need to get this object, so I'm just not going to provide a getter for it. Because I don't provide a getter for it, no other class can get to it. It's private, it's encapsulated inside this class. That's a good thing. Now, the setter method, I'd have to think about whether I want to actually include that in my die class. So this, even though I've restricted the values so that now the value has to be in a certain range, and I'm going to take out that 6 and put in sides. Because I do that, I'm only allowed to set the face value to be valid values, so between 1 and the number of sides. But do I want to do that? So this basically would reflect a user like picking up the die and placing it down with the 3 facing up or whatever number they want. Well, it really depends on how I'm using my die. Perhaps I'm playing a game where a user is allowed to, set the die to whatever they want it to be. Then I'd want to include this method. But if I'm using a game where I'm writing a game where I don't want the user to be able to do that, I want them only be able to generate a new number by rolling it, then I just wouldn't include this method. And if I didn't include this setter, then there's no way for the user to directly set the value. So for some instance variables, you need to think about, do I want to provide a getter and a setter or not? Sometimes I don't want to provide either. Sometimes I might just want to provide a getter. And then sometimes I might want to provide both. So it really depends on your program, how it's going to be used. It depends on what the variable is in that class and what it represents. So it takes a little thought, typically, about which of these you want to include. Okay, so I would not recommend just, brute force going in and putting them all in there for all variables. Give a little bit of thought about, does it make sense to have a getter? Does it make sense to have a setter? And then if it does make sense to have a setter, think about how you want to use that setter to restrict the values if that's something that makes sense for that variable. Okay, so that is the summary of what all of your classes should contain. And I'm going to walk through 2 more practice exercises here. We're going to write a dice class and a class for media items, and we'll do that in the next video.